Today we're going to talk about phase diagrams, and what we want to be able to do at the end of this is just be able to interpret one for any kind of substance. So what a phase diagram is, it's nothing but basically like a chart or a kind of graph indicating conditions at which a substance can exist at different states of matter. So usually they'll represent the pressure and the temperature and the different state of matter that a substance can be in. What you're seeing here is the phase diagram for water. So you can see here the different temperatures and pressure in which water can either be a gas, liquid, or solid, depending on the conditions. There are two important points to kind of focus on and know about, the first being the triple point. The triple point is a set of conditions where all three phases of a substance can exist in equilibrium with one another. And what that means is that a substance can change between solid, liquid, or gas. Basically any of these can exist at this point, and it'll kind of like alternate between them. Okay, so it'll go from being a solid directly to a gas, back to a liquid, and then back to a gas, and back to a solid. It'll just go between the three. So all three are possible at the triple point, hence the name. The critical point is the temperature and pressure in which the liquid and gas phase sort of coexist with one another. Sometimes where you hear about supercritical fluids, that's a substance that is a gas but has the density of a liquid. So basically these two phases at this temperature and pressure kind of start to merge with one another. So the phase diagram is really pretty simple. Okay, just two conditions of pressure and temperature for a substance, and it'll just help you identify, what state of matter or what phase of matter it's going to be in depending on the conditions you have. And once again, this is water. The lines basically just indicate transitions happening. So as something goes from solid to liquid, well, we know that's melting. So the little line between them kind of shows you when things are melting. Same thing with the line between liquid and gas. That would be boiling or condensation, whatever it is that you're looking for. So just some examples of what you could be asked in order to find out. With a phase diagram, one question could be, what's the normal boiling point of water? Okay, so then knowing that, the normal boiling point means at a pressure of 1 atmosphere or 101 kPa. So when the pressure is 101 kPa, okay, we're looking for the boiling point. So boiling point means it's going from a liquid to a gas. So we're going to look for the line at 101 kPa. When it starts going to transition from a liquid to a gas. So just moving over here, here's that line, liquid to gas. Well, that's 100 degrees. This is already common knowledge for us. We know that water boils at 100 degrees centigrade, but this phase diagram kind of helps to prove that. Another question we could be asked here, just an example, what pressure is required if you want to make liquid water at a temperature of 50 degrees centigrade? So just kind of estimating here. Here's 50 degrees, okay? So if we want to make liquid water, we'll just see what pressure is required when it starts turning into a liquid. Right around here, maybe I'd estimate about 20 kPa of pressure is required. So with the phase diagram, you can kind of figure out a lot of things about the phase changes of a substance. Every substance will have their own unique phase diagram. So this one here is for water. I wouldn't be able to use this for anything but water. Okay, so everyone's going to look different because they have different properties and require different conditions for different states of matter. So phase diagrams are very, very unique to the individual substances.